Okay guys, in this video we're going to be looking at just how the substructure search works on PubChem. So we're going to start by looking at this periodic table, and we're going to take a look at carbon. As you see, it has an atomic number of 6, so it has 6 protons and 6 electrons. It's in the 4th column, so it has 4 electrons in its outer shell, 2 in the 2s orbital, 2 in the 2p orbital. So it wants to make 4 bonds, and that's in order to achieve the octet rule. And that's really what gives carbon its unique chemical reactivity, which is why it's found so ubiquitously in all biosystems, where it serves as the backbone for nucleic acids and proteins and lipids and carbohydrates. Anyway, we're going to go ahead and look at octane over here. And that's found in petroleum products, and it's a hydrocarbon. And this is a bond line structure for it. We have 8 carbons, and they're all bonded out to hydrogens. Anyway, all the vertices in the line indicate a carbon atom. And unless indicated by an explicit formal charge, the carbons are assumed to be fully bonded out in neutral. So if we're looking at this carbon right here, the 4th one in the line, this one is bonded to 2 neighboring carbons and then 2 implicit hydrogens. And that's going to lead us into how the substructure search works. Wherever you have a bond to an implicit hydrogen, that bond can serve as a point of attachment for the superstructure. Anyway, we're going to take a look at that right now. So we're going to go to the PubChem Substructure Search tab. We're going to open the molecular jar. I'm going to paste in a smile string for the compound we're going to work with and press enter. And here it is. And what we're going to do is we're going to make all the implicit hydrogens on this ring explicit. So I'm going to do that right now. So I'm going to draw these in, and they're going to be explicitly shown within the bond line structure. And then they're going to be explicitly shown within brackets in the smile string, as you see. But we're going to leave this one carbon open. So all of our superstructures that are returned can be attached right here or up here at the alpha keto carbon. So we're going to go ahead and press done and search. And I already have the search conducted. So I'm going to pull that up right now. As you see, we have over 700,000 results, a ton of them. If we click on this first result right here, let's look at another one. Yeah, let's look at this one right here. Okay, if we look at this one right here on this benzene ring, we see a hydroxyl group attached to that carbon that we left open. And that shows you we can have superstructures attached if we leave implicit hydrogens there. Now what we're going to do is we're going to go back and we're going to close that one up. So I'm going to go back to the substructure search tab, open the molecular jar, and we're going to close that one up. So we're going to include an explicit hydrogen there. We're going to press done, search. We're going to go back. I already have the search conducted. And we look right here. It's cut almost in half. There's a little over 300,000 results. If we click on the first one, we can look right here. We see on the benzene ring, that one does not have a superstructure attached right there. There's a hydrogen right there. And that's one way to limit your searches. And that's how it works in general. Thanks for watching.